Hi, YouTubers. Hope all is well. Uh, I'm out in Western Pennsylvania, USA. Um, just want to show you briefly a small, inexpensive, easy to prepare, small water electrolyzer. I got the container from the local Goodwill store. Got them on sale for about 50 cents each. And I have inside there these gas tubes. Those that work in a chemistry lab, particularly an organic lab, would know over the years these very handy gas tubes for passing gas through, or molecular sieves, anhydrous calcium chloride pellets to keep moisture out of organic reaction going on, or just to dry any gas going through. And old toys, new games, huh? So these are very handy. We've got a couple of lengths in the stock room. These are the shorter ones. And I'm in my office right now. And this is the electrolyzer unit. Got a couple of those gas drying tubes inside the somewhat opaque container, and gas outlets for the hydrogen and oxygen. And also, to complete the circuit, I put a small hole in the cap, and the circuit can be completed. And that's where I hook up the electrodes that we're studying. And they'll be tucked inside those tubes. Now, in Walmart, in the craft section, sometimes you find something with completely different intended application. I can get these stainless steel clasps. They come in different sizes. And those working at home may be interested in this. Here's a bag of them. And they come in different sizes. It's in the craft section. Stainless steel. We're going to nickel plate them because we're working with nickel electrode deposited on the graphite felt. So that's how I get my connection. And after nickel plating, a little bit of solder to connect the wires in there. And we want to determine the current density, one of the important properties of an electrode. Now, don't pay attention to these graphite felts. They just were handy for giving you an idea of the area we're using. We run ours maybe 2 centimeters by 5 centimeters. But here's the typical graphite felt that we use. It's commercially available. We clean it very thoroughly. We have a procedure for cleaning. I've not oxidized the surface of the graphite felt as received with permanganate and acid, other techniques, but we certainly clean with isopropyl alcohol with gloves on. Of course, we don't want any oil on the felt. Now, the felt is conductive, but it also has a degree of surface area. And we continue our studies with scanning electron microscopic examination, about the 10,000x magnification. So as we electrolyze water, we use 20-25% aqueous KOH. As we electrolyze and produce the gases, we're going to be able to determine the current density for the electrodes as time progresses. We nickel plate the graphite felt, and that boosts the conductivity. We'll also be plating out nickel cobalt alloys and some other things we have in mind, such as preparing a polypyrrole semiconductor, but that's another story. So anyway, after we hook these up and we fill this little unit up, the gases then can pass through the neoprene tubing. And I have here an H-Tech. This is commercially available, German-made, very well made. I've used this for years with a small solar cell to photolyze water. And you can do a reverse process too with this, and the gases then can run through to provide you with current. So you can get these small, inexpensive hydrogen fuel cells. Here's one on eBay. But if you do this type of work that we're doing, make sure you have inlets on both sides for oxygen and hydrogen. Don't just use the oxygen and air for this setup. So you want your gases then, which are humid, and that's a good thing, incidentally, for this scale of study. We would wet a tiny bit with deionized water, the PEM in there, and then the gas is produced. We'll note the current and the amperage at the start of a run. We'll let it go for hours, and then we will hook up the electrical output. You can see the anode over here. For the oxygen, that would be the anode, and on the other side is the cathode, where the hydrogen gas will be running. And we hook this up to our ZB monitor so we can follow current voltage values in real time. So in other words, a very simple setup. If you're interested in working with graphite felt, modified in any way, and then after we do runs, we're able to examine the surface and look for any occlusion of impurities, changes in the surface of the electrodes. And this is how we start our undergraduates who are interested in energy storage. Start very simple, collect data, begin to analyze. So we'll keep you posted when I'm at school and we have one of these running, and you'll see the whole system set up. And gas is produced, separated, passed through the hydrogen fuel cell. We're also going to be working with some experimental membranes we're producing at school as plausible substitutes for Nafion, which everyone knows is very expensive. And that's another story as well. I'll sulfonate some derivatives of polyvinyl alcohol. But this is an excellent way for someone working at home or someone who, as I said, is an undergrad wanting to get involved. And water electrolysis is certainly an excellent, excellent area for young people to get involved. And we'll keep you posted on what kind of numbers we're getting on the current density calculations. Thanks for watching. Bye for now.